Okay, today's the 25th. Yesterday I said it was 25th also, so today it is the 25th. We're factoring special cases. So what happens if there's no middle term? For example, x squared minus 25. So there's no middle term. What I mean by that is, remember, the formula looks like this, and there's nothing with x in it. You've got an x squared right up front, you've got a number at the end, but there's nothing with x squared in it. Okay, so we do it the same way. There's we want the numbers to multiply to be the first number, and multiply to be the last number, and add up to be the middle. In this case, got to multiply to be x squared. Well, that's x and x. We got to multiply to be negative 25, and we have to add up to be the middle. But the middle in this one, there's no middle, so it's like 0. It has to add up to be 0. So in this case, it has to add up to be 0, in which case I know negative 25 would be negative 5 times positive 5. Now, when you check it out, you can always check, because when you add, you only add the inside and the outside. All we care about is adding these two together. So the inside is negative 5, the outside is positive 5. That's added up to be 0. This is the answer to the question. So this whole thing right here is what we want. Let's try another one similar to that one. What if we had 6? Is that too low? Maybe that's too low. Let's go up here. 16x squared minus 81. Okay? Now then, the cool thing about this is we know that these things have to be square roots. That's the whole trick here. So I know the square root of 16 is 4 and 4. To get x squared, you have to have an x and x. And then the square root of 81, I know, is 9. And so this one works. Remember, it has to add up to be 0. Look here, this is negative 36, these two. This is positive 36. When you add them together, 0. So the answer to this kind, when there's no middle term, pretty easy things to do. You take the square root of the front number, the square root of the back number. One's plus, one's minus. That's the way it always works. Okay, perfect squares. The next kind, if we had something like this, let's see, where can I write that? Right there. X squared minus 8x plus 16. Okay? Now then, what does it mean? Well, we always start the same way. How do I make this front number? X squared. How do I make this back number? Oops. What am I doing? How do I make the front number? X times x makes the front number. How do I make the back number? 4 times 4, right? 4 times 4. But when I add those, I get positive 8. Whoops, I want negative 8. So it's negative 4 and negative 4, right? So what it means by perfect squares, whenever we say perfect squares, is that these two things are exactly the same. See, these up here were not. They were almost the same. This was a plus and that's a minus, right? But these two are exactly the same. They're both the same sign, negative 4 and negative 4. Right? So there's another way to write this answer. If you want to, and IXL lets you have this opportunity, you can write it like that. Yay! Right? Let's see. Let's try another one. So here, is that going to fit right there? I think so. 4x squared, and then plus 40, and then let's x, and then let's do 25. Okay. Now then, see if we can see if I did that right. Let's see. 2, whoops, that's an x squared. And then that one is a, so this is 20. Okay, let's try again. Alright, so I need to find the numbers that multiply to be 25, which I'm going to say are 5 and 5. Right? And they have to be the same. And then to get the 4, I'll betcha it's 2x and 2x. Now, let's see. Inside is 10. Inside is 10. That makes 20. Hallelujah. We did it. Right? And so that's 2x plus 5. And 2x plus 5. The little light got in our way, so let's move this down here. 2x plus 5. 2x plus 5. It's the same, 2x plus 5 squared. If they're both exactly the same, then you can put it in squared. These are so close to being the same, but see, this one's a minus, that one's a plus. You cannot put that one in squared. This one same way. Okay, what if something was common? Well, I could have, let's try, 3x squared minus 75. All right. So if something is common, this still doesn't have a middle term, does it? So we know something's going on. It's going to look very similar to that. But there's a number that's common because I can divide 75 by 3 and I can divide 3 by 3. So remember what we did the other day is you have to take what's common out and then you have to write what's left. So if I divide by 3, x squared is left. If I divide by 3, 25 is left. See? Now, look, it's the same as the one up there. So that would give me 3 on the outside. You always have to leave that 3 there. And then x plus 5, x minus 5. Right? So it doesn't matter if the number out in front, I mean, as long as the number is divisible into both the numbers, you've got it made. And that's what they're going to give you, things that look like that on today's IXL. So you're looking for numbers that are common. And if you can find those numbers that are common, then you are in business. Let's do one more. So what if we did 12 x squared and 60x and 75. I just love 75. We're just going to go 75 today. Alright, so I look at this and I say, well, these are even, that one's not, this one's divisible by 5, but that one's not. Okay, so 3. 3 divides into that, 3, okay, 3 it is. Let's go with 3. Now remember, the first step is to take out what's common. So if I divide that by 3, I get 4x squared. If I divide that by 3, I get 20. And if I divide that by 3, I get 25. Ha ha! Hoorah! Okay. Now then, this one, remember, you can break it down. Well, the 3 has to be out in front. And then you have to find numbers that multiply to be 4. X and multiply to be 25. And so, okay, so we got, well, we did it right here. Look, see, this one's the same. So, I can just write that. 2x plus 5 squared. How do I know that? Because 2 times 2 is 4, 5 times 5 is 25, and then 10 plus 10 is 20. So see, this is the answer. This is the way I write it. And that's all. Now you can do today's homework. Bye-bye.